I'm going to go on a journey to search for the smallest thing. The smallest thing. How do we measure the things in science? Well, one of our references is the meter. And this meter stick is a little bit larger than what you can see on the camera, but that's going to be my first reference. So, about a yard there, I've got the metric measurements pointed towards you. This is about a yard plus 3 inches or so. This is the meter stick, so it kind of spreads this idea out to us. You can see the whole meter stick. That's great. Now, what's the smallest thing that you can see with your eye? And certainly when we talk about see, we normally are talking about light entering our eye. Light reflecting off something really small, and it enters our eye, and then our brain figures out that there's some kind of image that we can get from that. We'll go through a slide here where we talk about the smallest thing that your eye can see, and then we'll compare the dimensions of that smallest thing to this yardstick. I'm sorry, it's a meter stick. If you're a scientist, you don't use yardsticks, you use meter sticks. Anyway, we'll talk about that. And then another slide, I'll talk about how tiny we can provide an image with an optical microscope. In other words, lenses. Lenses we can use those as long as we have enough light that'll get up to our eye. We can see things really small if we magnify things. And I'll have a little description of how a microscope is set up. I don't really have a good drawing of it. It's better if I use a slide to show you that. Okay, so I'll show you what the limitations of the optical microscope is, and then, limitations are, using correct grammar, limitations are of an optical microscope, and then we might say, okay, that's it. That's as much as we can see. That's the smallest thing we can see. That's the smallest thing we can actually identify or come up with an image of. That's not the ending. We also have these things called electron microscopes. We know what electrons are, so how can electrons be used to come up with an image, and do we trust that image? That's the next question. So we'll have a slide that shows the smallest thing you can see with your eye and come up with some dimensions there. Your eye has certain limitations, and that's the best it can get. And then we'll use an optical microscope, and sometimes we can have the optical microscope enhanced by a bunch of pixels that pick that up. In other words, a video type camera that will pick those up. Then we'll look at the limitations of what the smallest thing that can see. I guess we still see because the light is entering our eyes, or it's going onto this camera image. And then finally, we'll have a slide for an electron microscope and see what if there is any limitations at all, or can we just keep going smaller and smaller and smaller until we see a neutron or a proton or an electron. Wait a minute. How can an electron see another electron? I'm not sure that that's possible. Anyway, eventually we'll reach a point where we run out of gas on the electron microscope, and we have to come up with some other methods to find what's smaller than this smallest thing that we can see. Okay, that went by a little bit faster than I promised. But on this meter stick, it's divided up into 1,000 parts. And your eye, from what that last little video thing showed you, your eye can only see about 1/10 of each one of these small marks on this meter stick. The wavelength of light is only so long, and you get down to dimensions that are close to the wavelength of light, then you can't resolve anything closer. So what you do is you take electrons and accelerate them with high voltage, and that creates a high frequency electron, and that means that the wavelength becomes very small. And then, as you saw at the very end of that video, you were actually looking at carbon atoms. There's just a little spots there where the carbon atoms were. You could see that they were circular, like maybe you would have expected, but we can't get inside that atom to see what's going on. And that's where we're headed next. What do we do to figure out what's inside those atoms? How can we figure it out? How can we draw a picture of it? And that's where I'm going with the next one.